In this section of PPST, we will look mostly at place value and at the magnitudes of numbers. So let's look at this word numeration. Numeration is just our process for naming numbers using place value language. We have place value, and place value is going to give the value of a digit a place. Therefore, when we write 1, 2, 3, we really mean 100, 2 10s, and 3 1s. We can look at expanding our place value. For example, 352.19 or 352 and 19 hundredths. We can express it as place value. We know that the 3 is in the hundreds place value, and we know the 9 is in the hundredths place value. Therefore, we can read the decimal as 352 and 19 hundredths. And we can express this as a mixed number as 352 19 over 100. Let's look at the place value as it is based off of our powers of 10. If we go to the right and left of the decimal, we have our place values. Over on the left of our decimals, we have our ones, tens, hundreds, and so on. Each time we're getting 10 times larger as we move from one place value to the next. After the decimal, we have our tenths place value, hundredths, and thousands, and as we move to the right of the decimal, we get 10 times smaller. We can use this place value to decompose our numbers into powers of 10. Therefore, again, we had that number 352 and 19 hundredths is really just 3 groups of 100, 5 groups of 10, 2 ones, and then we can look at our place value of tenths and hundredths. Our 1 can be represented as 1 times 1/10, and our 9 is in the hundredths, or 9 times 1 over 100. Again, place values can be put in exponential form. Therefore, thousands is really 10 times 10 times 10, or 10 cubed. 100 is 10 times 10, or 10 squared. Tens are 10 to the 1, or 10 to the first power, and our ones is really 10 to the 0, because as we raise 10 to the 0, we get 1. Tenths, which is 1 over 10, are represented in decimal form as 0.1, is really just 10 to the negative 1. Hundredths is 1 over 100, or in decimal form 0.01, can be represented in exponential form as 10 to the negative 2, and so forth. Exponential form is often used in scientific notation to express very large and very small numbers. So as of July, our national debt was $14.6 trillion. If we wrote this in expanded form, we would have 146 followed by 11 zeros. In order to write this in a more compact form, we can express it in scientific notation. In scientific notation, we have kind of our lead number followed by 10 to some power. We can see that in order to move our decimal place to the left, we would have to go 13 places in order to get to 1.46. Therefore, we have 1.46 times 10 to the 13th. In scientific notation, we can express it as the form a times 10 to the b, where a is just some number from 1 but less than 10, and b is some integers. For example, the takeoff weight of a Boeing 747 is 439,985 kilograms. We can represent this by using our scientific notation, moving the decimal place 1, 2, 3, 4, 5 places to the left, or 10 to the 5th, or 4.4 times 10 to the 5th. The weight of a single M&M can be expressed in scientific notation by moving the decimal place to the right 3, or written as 1.9 times 10 to the negative 3.